Topic 5.9, the impacts of mining. Everything, all the products we use, especially the fun ones like the electronics, use elements that we need to mine out of the ground, and it is an environmentally destructive process. It always has been, but there's things we can do to make it better. Now, lately, we've been, you may have heard in the news, there's a bunch of talk about rare earth elements. So I thought I'd throw this in here. Rare earth elements, they're kind of misnamed. They're not rare, but they're hard to get. You have to really go after your ground. Like you got to dig up a lot of ground. You got to do a lot of smelting, a lot of chemical processing of the ore, the rocks and the dirt that you get out of the ground to get the rare earth. So most countries would rather not do that. They have all that waste and pollution in their area. So lately China has been doing a lot of that. But as you know, we go back and forth with issues with China, with trade and so forth. But we could do rare earth mining in our country, in the areas that we have that are friendlier to the United States. But it is destructive, so you really tend not to do that. But if you look at the periodic table of elements, you can see the rare earth elements in this area here. And what happens is they're popped down into here, the lanthanides. So that's what rare earths are. So we move on to something that you're familiar with, cellular telephone. All of these elements that are in there, the electronics, gold, copper, silver, tantalum, tungsten, the battery, mainly lithium, aluminum, cobalt, and your earbuds, the touch screen, the speaker. Look at 40 mined minerals needed for a single smartphone. So mining is essential for what we use in our normal everyday lives, and you don't have to go too far to see mining. This is one of the world's largest open pit mines. They're mining borax in the California desert. If you go out towards Palmdale, Lancaster, out towards Las Vegas, you get to the Mojave Desert. This is where this is happening. Oops. The Mojave Desert. Okay, and borax is used in industrial processes. Basically boron. And a lot of laundry detergent used to have a lot of borax, and you'll see 20 Mule Team borax on the laundry shelves. That is from the United States. I'm sorry, California. Here's a overhead view. It's a huge open pit mine, just a giant hole in the ground that they just dig and dig and dig, go deeper and deeper. And it looks like over here, I bet you these are tailing ponds we'll get into in a second. But these are waste management contraptions to try to, a lot of times you use water in mining processes. Now, we know a lot about gold and silver in California, the gold rush of 1849. And the most famous one is Sutter's Mill, and that's what this picture is showing. Sutter's Mill, where they first struck it big on a tributary, I think, of the American River. And then everything else is history. Then California's economy, population really started to boom. Yeah, here we go. Sutter's Mill up on the, looks like, above current Folsom Lake on the American River. Probably about 150 miles, 200 miles from Sacramento. But even closer, this is Azusa. Over here, on the other side, right here is Monrovia. City of Industry. Downey is down here. Oh, that's Monrovia here. And it goes over there. But 605 freeway. Go back to good old red here. 605 freeway goes right through here. And you see big mines here, big mines here. And these are all gravel pits. You know, they're mining gravel. Okay, so we have mining very close to here within 20 miles of Jordan High School. Oh, here's another, that's another image of that borax mine out in the Mojave Desert. So, as mining happens, you know, you get the easy stuff first, but then it starts to get more difficult, more difficult. You gotta dig deeper, deeper. You gotta add more chemicals, more energy to mine. So, as the more accessible ores are mined to depletion, depletion, of course, running out, getting lower amounts. Mining companies need to access lower grade ores, and that uses more resources, more water, energy, chemicals, electricity, whatever you're using for energy, and that is going to increase waste and pollution. So older mines can be at higher risk for, you know, being likely to pollute as you're just kind of getting the the dregs. Here's some different types. We got surface. That's that borax mine that we just saw. Underground mines, you see some of this, especially for coal on the East Coast, but also some of these for there's some old gold and silver mines near us in Southern California. Placer mining is when you kind of just go to the side of the river and blast it. That's for, you know, gold, you know, used a lot in California. And then in situ mining. And that's a pretty wild, where you chemically dissolve. Say you want to have gold, so you pump down chemicals like cyanide and others to dissolve the gold, and then you pump that solution to the surface, and then you re-extract the gold. Sounds pretty wild, and it is. Of course, you definitely run the risk of, you know, doing massive amounts of pollution. So I've not experienced with mining, so I just want to show you how some of these mines work. The one I showed you pictures of in California is big open pit, cheapest, easiest. You just start digging. Then you have these other types where you dig shafts into the ground. You see this one in the middle has this incline shaft, and there's this seam of whatever it is you're mining, coal, gold, silver, and every once in a while you just cut a new little layer to go after that mineral deposit. And then there's a more vertical shaft. We just go down, and then you go horizontally directly into the ore deposit, and you're just digging and digging and trying to strike whatever it is you're trying to find. So the way surface mining works is you remove large portions of soil and rock. The removal, and that's called overburden. So put that into your mind. That might come up on the exam, overburden. So let me write that again, overburden. That's, the unwanted stuff, unwanted rock usually. Unwanted rock and soil above what you're trying to get at. Your copper, your gold, your coal, whatever it might be. An example is strip mining. So just stripping everything off, removing the vegetation, making it, and when you do all that, you make it more susceptible to erosion. And that erosion then can go take away the mine tailings and stuff in the mine, and that's extremely destructive. All right. So let's talk about the ecological impacts of resource mining. This picture is from a mine in, looks like a tropical area. I believe this is Brazil. You can see right on top of this mountain, and of course the water is going to drain off here, go into the slate, go into the watershed, and make its way through the ecosystem. So there's ways we can help out with this, but all these wastes, we got soil waste, rock waste, all that is remove that overburden in order to get to the ore, the copper, the gold, the silver. And the waste part, that's called slag and tailings. So what you don't want, what you are left with at the end, that's your slag, that's your tailings. And let's see, mining, the way it's done now, it's done create low-cost energy and materials. Energy in terms of mining coal, oil, natural gas, minerals. So energy, coal, oil, natural gas, and minerals like gold, silver, copper. Mining coal can destroy habitats. Well, mining anything can destroy habitats and contaminate groundwater. That's the big concern. Mercury, copper poisoning, and dust particles, and methane, that greenhouse gas. This is an example of what happens when there's a failure. So I believe this is down South America, a copper mine. They have the tailings all stuck behind this big dam, and guess what happened? The dam broke and all this highly toxic material washed into the local river, the local stream, and then it's going to go have massive devastating impacts. This right here, this is slag from copper, smelter. Let's put that up there. Smelter. What a smelter is, that is a it's basically a factory that takes all of the rocks and heats it up and separates what you want from what you don't want, separates the copper from everything else. And they produce a massive amount of air pollution. So say it's a factory, that's probably the best way to put it. Factory, it separates the ore from the overburden stuff. Okay, whatever, the rocks, the dirt that contains your ore, the smelter separates that, and this is what's left behind. You don't want to get involved with that stuff. This is in Chile. This is in Canada. This is the big tailings mine. And what are the chances no leakage is happening? Probably pretty small. And remember, these dams can always fail. So this is closer home. This is in our state. This is kind of our California legacy. We had so many gold mines and mercury mines in the Sierra Nevada. And those, all the tailings, they're still running off into our lakes, rivers, and streams. So right now in California, we're still dealing with this. From over 100 years ago, it'll be 200 years, not too much longer. So they still to this day are monitoring these old gold mines up in the Sierras to check for these high levels of mercury that often come out of them. Now, mining is essential. We've been mining for thousands of years. It's what we built everything on. All the goods that we make are all from mined materials. But there's ways to make sure what we leave behind, and while we do it, we're not creating an impact greater than necessary. For example, here you can see artist's rendition of a restoration of an open pit mine. You can manage it in a way when it's done, you can try to restore that habitat best you can. Azusa, that mine that I showed you earlier, right at the north end where the 605 ends near Monrovia, there used to be these giant terraces cut into the mountain there in a kind of shape of a triangle. They call it the Mayan pyramid. Finally, that mine was required to remove those terraces, to take them out and smooth it out and make it look more natural, which for me was kind of strange not seeing those terraces. But now it has a better chance to restore itself over time. So basically, we need to reduce the impact, the footprint of those mines. Now, perhaps digging underneath in those shafts, it can reduce the footprint. These open pit mines have a really large footprint. But the ways we can help reduce our footprint is to recycle things more, so we're not having to mine them. So recycling is big. So better ways to recycle materials and to reuse, and not to buy so many things. Okay. I'll say buy less stuff. I'm definitely guilty of buying more than I need. But if we buy less stuff, then we greatly lower the impact on the environment. Specifically, having to mine more materials to make new products.